Let's review the foreword through Chapter 2 of Clean Architecture by Robert Martin, aka Uncle Bob Martin. This book was published in 2018 and it's part of a larger series. In the foreword, he ponders the word architecture and says that it's not obvious that software obeys our intuitions about construction, but I think it does. I think it's a really intuitive word, and I disagree with this pondering in the foreword. He says that software is recursive and fractal, unlike construction, but the truth is recursive functions are usually not a good pattern, and in material science, lots of materials are fractal as well. He says it doesn't make sense to talk about physical scale in software, but like horizontal scaling is literally physically scaling your machines, so it's perfectly intuitive. I'm glad I did this because I think later he contradicts himself on this and ends up saying that physics is a great analogy, basically. Here's a really great quote in the foreword. If you think good architecture is expensive, try bad architecture. I think this is an ideal mental model, and I'm bringing a background of economics that I think was really missed in a lot of the book, but this foreword, this particular quote, calls it out, and I think that's great. At times in the book, some talk was metaphorical, and I think it was even like hyper-metaphorical and a little bit confusing. Architecture is a hypothesis. If we're speaking artfully, fine, but technically it's not. So when you're reading this book, keep an eye out for when is he being literal and was he being like metaphorical or artsy. Here in the preface, which is not the foreword, he says that he built a bunch of systems and realized the rules of architecture are similar throughout all these various architectures. And I think this is great, and this is in contradiction to the foreword. So this does establish the fact that software has to obey laws of physics and logic just like construction does. Now we get to chapter 1, the introduction, and he basically introduces the concept of architecture by saying it's easy to build something, it's hard to do it right. And I really hate this dichotomy because the truth is building anything in software can be hard, and getting it right is giving like the one true way problem, which there's a billion right ways to do stuff in software engineering. So I really don't like this intro. I wish he would have said profit, that not every way to build a system is equally profitable. So we need to target architecture that maximizes profitability. But he's missing that like economic lens totally. So instead of optimizing on profit, he wants to minimize effort. That's his definition of a good target architecture, that changes are easy and cheap. Again, the problem here is that sometimes we want tech debt for business reasons, and sometimes we want a piece of your system to be difficult to change. Like when we introduce tests and failing builds, we're increasing the time and effort it takes to make a change on purpose because we realize that some components of the system are valuable and we want to make change frictionful sometimes strategically. So that was the introduction of part 1, which is not chapter 1. I think I misspoke there. Here's chapter 1, what is design and architecture? I actually love one of his takes here. He says, I'll assert that there's no difference between them, none at all. I actually really love this take, and he does a great job in later chapters of identifying an ideal architecture as following scientific principles. And we know design thinking has to follow scientific principles. So the scientific approach to the whole book, I really love that aspect. And we know that it means that any architecture must be living and adaptive if it's going to be using the scientific process where we try something and then iteratively improve. So this is like a meta architecture, as opposed to if you look at a time slice in your system and say, what is the architecture right now? The way he's using the word architecture here is kind of like the idea of meta architecture, which is really great. And I also love this other take where he respects the low-level details. I think when some people talk about architecture, they want to talk about high-level system design and they ignore the low-level considerations. But he respects the co-equality of high and low-level architecture, which I think is super awesome and important and slept on in other places. A little more disagreement. Again, he reiterates that minimizing effort makes a good architecture. I don't think minimizing effort is the right frame, or at least it's like a simplification of the right frame. I think we want the risk-adjusted return on investment to time and effort. So not just effort alone, but also time, adjusting for risk. So, I mean, if that's what he means, cool, but it's pretty clear in the book that's not what he means. He's literally talking about making it easy for developers to change a few lines and alter the system, which is sometimes actually dangerous. He says, if the effort grows with each release, that's a bad design. I'm cool with that as long as we add in the long run, but in the short run, tech debt is a tool and we need to know how to use it. It's not the case that short run taking on tech debt is a bad architecture if you're approaching this with the lens of maximizing business impact. And he goes on for a case study where basically he says like growing engineering staff can be a bad thing, which is not true, right? And then he uses lines of code as the measure of productivity. That's like a terrible measure of productivity. So the fact that lines of code are decreasing in scope over time does not mean that there's a problem. He says clearly there's a problem here. That's not the case. What we can see here is changing lines of code is happening slower. That's not necessarily bad. You need to do profit analysis. And he does cost analysis, which I see a lot of engineers confuse cost analysis and profit analysis. These are not the same thing. If I'm spending more and making a higher return, it's worth it. So here I say the problem with this framing is the idea that an expensive architecture is a bad idea. The truth is we can always get better is the right frame. You don't want the cheapest possible system. You don't want the easiest to change possible system. You want the system that is going to make you the best return on investment. So a lot of things to criticize, but a lot of things right here. If you take the scientific lens, that really shines through, and that's really consistent with what I'm saying. So later when he talks about testability, falsifiability, I'm 100% with that, and we can harmonize that scientific approach. It really is more in line with the we can always get better approach, right? So I think the we can always get better approach is, first of all, just like clearer, more intuitive, more in line with reality, but also harmonizes better with the business principles instead of minimizing system cost or maximizing change speed. He goes on a rant where he's like, hey, like once tech debt's in there, it never gets cleaned up. Well, that's not true. It may be rare, but sometimes it happens. And what I wish he would have done is teach developers to make a business case. What you need to show is that, hey, refactoring this or fixing this code or adding these tests is going to generate profit impact to the business. And if you can do that, it totally gets prioritized. So the reason that it rarely gets prioritized is not because like managers hate clean code. It's because there's a skill gap in making a business case for these improvements. He goes on a bit of a side quest with TDD. This so-called experiment is not scientifically valid. It really doesn't show anything. This is one guy on 6 different days. So there's endogeneity problems, all sorts of problems. And the only way to go fast is to go well. This is not true. This misses the idea that you can strategically take on tech debt in the short term. He misses a great opportunity to talk about the iron triangle. He talks about the executive's dilemma, but it's actually a false dichotomy. The real solution here is the iron triangle. He ignores the option of greenfield and migration. He basically argues that like once a system is bad, it's never going to get better. Well, you can totally just build a different system and migrate, right? That's something businesses do all the time. And then he argues that like the solution here is that engineers just need to advocate for quality and accept the responsibility of their systems. I don't know that I like the idea of developers should just take more responsibility. It feels like if you preach that to your engineers, a bunch of them will quit. I think the better approach is to teach them to make business cases. And then executives are not going to cede their responsibility or their power. But what they can do is if you persuade those executives, they will prioritize quality improvements. Chapter 2, and this is not the theme of the whole book. There are good parts in the book, but it is the theme of the first part of the book, including chapter 2, that there's a missing important economic lens. So going back to poorly defining the target architecture, he says that an ideal target architecture should make changes. The difficulty of the change should be proportional to the scope of the change and not to the shape. But this is like totally mistaken. So feature-wise cost heterogeneity is optimal for most systems. So it's not the case that you need to design a system such that new requirements are equally as effortful as changing existing features. Like that is totally not the case. It can be a system where certain things are easier to do. That's usually optimal, actually. And we have architectural principles in place for this. Don't prematurely optimize. You ain't gonna need it, Yagni. So the idea, again, that like everything should be equally difficult and it should be sort of like a symmetrically difficult system, that's like not ideal. He says that there are these two values, behavior and architecture, and he's going to argue that architecture is the more important value. His argument here is based on logical examination of extremes. The entire examination here is flawed, and you need profit analysis, which he misses. So this entire take is wrong. It's not the case that architecture is more important than enabling behavior for your stakeholders. He finally talks about not only cost, but cost versus benefit, which is like, finally, dude, we're finally talking about profit. The problem is he talks about cost versus benefit within a system, and he doesn't acknowledge the possibility of making a greenfield new system and migrating. Eisenhower matrix, I'm glad he brought this up. This was really important to talk about. He tries to derive like another concept of architecture here, but it ends up being tautologized and just like orthogonal to the prior discussion. He says that it's the responsibility of engineers to assert the importance of architecture. I disagree. Don't assert it, prove it, learn to make a business case. And don't be an absolutist. You're going to be like an engineer that disagrees with management if you do this. The last piece I really agree with is remember as a software developer, you are a stakeholder. This is really important. And your company and your managers do care about minimizing churn and turnover and improving developer satisfaction and so forth. So include that in your business case. If there are changes that are going to improve employee retention, that is valuable to management. Follow if you want to hear about the next part.